Hi guys, I'm Devkiran Ravala. I work as a technical lead for a consulting firm called ZAM Consulting here in Sydney, Australia. We have different branches in different parts of Australia like Melbourne and Brisbane. And we also have a team in Philippines as well. ZAM helps your .NET teams to develop custom applications and make them self-reliant. We help deliver reliable .NET solution that caters to your goals and needs of your business irrespective of its size. We provide a full cycle .NET development services by leveraging your expertise in delivery of high performance process oriented applications and software products for web, cloud and mobile. Coming to me, I'm a .NET developer for over 15 years and currently I'm focused on web development using Blazor and mobile development using Xamarin. We'll try to understand what is a WebAssembly. Before we go into it, let's see what the developers themselves say about a WebAssembly is. So the www.webassembly.org, they say it's WebAssembly is a binary instruction format for a stack-based virtual machine. It is designed as a portable compilation target for programming languages and enable development on web for client and server applications. The most important part that struck me is what is a stack-based virtual machine. Let's try to understand what it is with a trivial example. Suppose your program needs to add two numbers. To do that into a stack virtual machine, the program will push a first number to its stack and then it pushes a second number and then executes some form of a special instruction, for example add, that will pop the first two elements which you added and then replaces them with their sum. So you have a code, you have a source code and you compile it and use that only at the end. All you need is the end result in a stack-based virtual machine. So that's exactly what happens in the WebAssembly as well. Let's try to understand more now. WebAssembly is a new programming language for web. It is an open standard and defined in a binary code format. World Wide Web Consortium W3C developed it. Most modern browsers supports it without any added plugins, which were required for the older technologies like Flash or Silverlight. If you remember them, you need to add the plugins. But in case of WebAssembly, it don't need any plugins and it should work pretty much straight away. It is similar to any low-level language, meaning that it can perform equal to any native language. WebAssembly is not something that a developer can write, but it is given to us and we can make use of languages like C#, F# or others, and they are compiled into WebAssembly. The same code where a JavaScript runs in the web browser. JavaScript is not the replacement of Blazor is not a replacement for JavaScript, and WebAssembly helps you to write high performing applications on the web. It is now already shipped, the version 1.0, and currently it supports Firefox, Chrome, Safari and Microsoft Edge. And what are the goals? When you think about it, they want this to be faster, efficient and portable. WebAssembly code is meant to run faster on different platforms, taking advantage of the hardware that it's running on, and they want that to be easy to read and debug. WebAssembly, being a low-level assembly language, has a text format support that allows you to debug the code for any issues and also to rewrite the code if necessary. WebAssembly is safe to run on a web browser as it takes care of permissions and same origin policies. And some of the advantages that you can see in using a Blazor, in the WebAssembly, it is a hardware independent, it is open and debuggable, it is fast and efficient, it is independent of any language that you're writing on, it is independent of the platform also. It's an open web platform. It is memory safe and it is quite easy to use as well. And when you think about it, there's a buzzword that going on is it going to replace JavaScript? But that's not the case, because WebAssembly runs faster in terms of execution, and the JavaScript is not going to is going to be replaced because of that. But that is not the case. WebAssembly and JavaScript are meant to work together. WebAssembly is dependent on JavaScript to interact with the document object model. It is designed to work with JavaScript and compatible with the other web technologies like HTML and CSS. Higher level languages such as C#, F# and others can be compiled into WebAssembly on the browser that JavaScript is running as well. Let's see how it is compiled. It make use of the interpreters, which meaning that language is not translated into the WebAssembly. So any language that you're writing in, it is not translated into the WebAssembly, but interpreters for the language written in the WebAssembly. Currently Ruby and Python only, and there's a way to do a direct compilation as well. At the moment, C++, and Kotlin have this native way to generate WebAssembly, and you can also make use of the third-party tools if your language is not supporting to generate a WebAssembly. A source code can be converted into a WebAssembly. What are its security? It has limited access to the computer machine. All the interactions are done via the embedders. WebAssembly translates source code to machine code and runs on host hardware. It is vulnerable for the side attacks on the hardware. Looking at some of the limitations, WebAssembly do not have direct support to access DOM or the browser API. WebAssembly relies on the JavaScript to interrupt to update the DOM and access browser APIs. It uses the Mono garbage collector to manage its garbage collections. So these are some of the limitations. And thank you for listening to this video. Please leave any comments or questions. I will try to answer them as soon as I can. Stay tuned for more videos. This is your host Divikiran Ravala signing off for today.